Hello, everybody. I am Biswajoy Chatterjee, Vice Chancellor of University of Engineering and Management, UEM Jaipur. And I am back again with another puzzle today. So I will solve another puzzle and show you that with games, computer games, what interesting relation mathematics can also have. I will be playing a computer game, and in that game there will be interesting mathematics present all round. So I will definitely show my screen first. So here, as you can see, the problem that I talk about is the Tower of Hanoi problem and recurrence relation. Tower of Hanoi problem and recurrence relation. For that, this is the picture. See here, you can see three towers. What are they? A, B, and C. Three towers are there in this picture. Now, in the A tower, there are few plates, as you can see. Plate 1, plate 2, plate 3, plate 4, plate 5. I'm sure it is visible. So, what you can see is this is the fifth plate, this is the fourth plate, this is the third plate, this is the second plate, and this is the first plate. As you can see, the plates are so nicely arranged. The biggest plate at the bottom, above that the plate having size one smaller than that, above that another plate having size one smaller than that, and so on, the smallest plate on top. Your job is to transfer all these plates from tower A to tower C. Your job is to transfer these plates from tower A to tower C. That is very simple. These plates will have to be there in tower C. What big deal? Nothing at all. What is the role of B then? See, this transfer of all the plates from tower A to tower C that you need to do has got certain constraints. What are those constraints? The constraints are that you can pick up only one plate at a time. So I go ahead. This was the question. A is the source tower, C is the destination tower, and this is an intermediate tower B. Forget about it at the moment. But you need to move all plates from source tower to destination tower. You may use the intermediate tower. And which one is the intermediate tower? B is the intermediate tower. You have got constraints. I told you. First constraint, you can pick up only one plate at a time. One plate at a time, first constraint. Second constraint, at no point of time, a bigger plate can be kept above the smaller plate. I repeat, you can pick up only one plate at a time. So you can pick up one. If you pick up one, you cannot pick up two togetherly. You can only pick up one plate at a time. So one by one, the plates will have to be moved from A to C. But the second constraint says at no point of time, a bigger plate can be above the smaller plate. So these two constraints make your job difficult. So is there any way by which you can transfer all the 5 plates from A to C without picking more than one plate at a time, only one plate at a time, and without keeping a bigger plate above the smaller plate at any point of time? Is it possible? See, for that the B tower is there in your hand, which you can use as an intermediate tower. But you see, if you randomly try, if you pick up one and keep it at C, then remember, two when you pick up, you cannot keep it in C, because one is there in C. You cannot keep two above one because two is bigger than one. But one thing you can do, if you pick up one and keep it in C, then you will have to pick up two and keep it in B. Then you can pick up again one from here and keep it in B. In this way, you can do some adjustments by which all the plates can be moved from A tower to C tower without without picking up more than one plate at a time, and at no point of time the bigger plate can be kept above the smaller plate. How to do? So let's play the game. So I go to the game now. I click on this and go to a website. I go to a game. You can see it's a game, and I give due credits to this website. The website is Maths is Fun stroke games stroke tower of Hanoi.html. I go to this website to play this game. See, over here there are 3 disks. I will have to move these 3 disks from A to C. Without that more than one plate can be picked up at a time. Only one plate can be picked up at any point of time, and at no point of time a bigger plate can be above the smaller plate. How to solve this problem? How to do it? See how I do it. Very simple. I pick this one up, keep it here. I pick up from A, keep it at C. Now if I pick this one up, can I keep it here? Answer is no, because a bigger plate cannot be kept above the smaller plate. So keeping over here is wrong. What I do? I keep it here. But then I will have to move all the plates to C. How to do that? If I now pick this one up, I cannot keep it here. I cannot keep it here. Why not? Why cannot I pick this one and keep it here? Because I cannot keep a bigger plate above a smaller plate. I cannot keep here also because I cannot keep a bigger plate above the smaller plate. So let me do one thing. Pick this one up. Keep it here. Then let us pick this one up. Keep this here. Let us pick this one up. Keep it here. Then let me pick this one up. Keep it here. Then let me pick this one up and keep it here. So see, it's written well done. They were talking about minimum moves 7. I have used 7 moves. I could do it. But what if the number of plates are not 3 but 4? Can I still solve the problem? See, now I have made the number of disks 4. I will have to move the 4 disks from here to here. See, but only one plate at a time, and never can I keep a bigger plate above a smaller plate. What to do? Let me pick this one up, keep it here. Let me pick this one up, keep it here. Let me pick this one up, keep it here. Then let me pick this one up, keep it here. Then let me pick this one up, keep it here. Then this one up, keep it here. Then let me pick this one up, keep it here. Then I pick this one up, keep it here. Then I pick this one up, keep it here. Then I pick this one up, keep it here. Then I pick this one up, keep it here. Then this one up, keep it here. Then I pick this one up, finally keep it here. This one I pick up, keep it here. And this one I pick up and keep it here. See, they were talking about minimum moves 15. I have used 15 moves. Is not it a game? What's there? What's math? Where mathematics is there over here? Do you see any mathematics? Can I use mathematics to solve this problem? In fact, when I was solving this problem, did you notice that I was just doing it as if all the steps are learned by heart? I just did it one after the other. It automatically came to me. Yes, because I was using some mathematics in my mind. Let me show you what. Let me do for 3. See, for 2, for 3, how I solve this problem. For 3, I know I will do this. I will solve this problem for 2, and then I will expand it. If I was given only these 2 disks and I was asked to do only for this 2, then what to do? I so easily could have done it. I would have picked it here, kept it in B, Then I would have kept it in C, and then from B I would have moved to C. So easily I would have solved for two disks. But see what I do over here. I will say for two disks, I will forget that there is a third disk. For two disks, I will solve this problem. I will try to bring these two disks to the intermediate tower. I will forget that there is a third disk. I will only solve it for two disks. I will pick up two disks and keep it in the intermediate tower, forgetting that there is a third disk. So for two disks, if I pick up and keep it in the intermediate tower, then I can pick up the third disk after that, keep it in the destination tower. Then again for two disks, I can solve the problem of bringing it from intermediate tower to the destination tower. See, very simple. I will not solve the problem for three. I will solve the problem for two. For two, I will pick this two and keep it in intermediate tower. For that, it is very easy. Then I will pick up the third plate and keep it over here. Then I will solve the problem again for two plates from intermediate tower I will bring to the destination tower. So now my target is only these two disks to be moved to the intermediate tower. How to move the two disks to intermediate tower? Very simple. I pick this one up, keep it at the destination. Because I need to move the two disks to intermediate tower, I keep it to intermediate tower. Then I pick this one up and keep it over here. Very simple. I have solved the problem for two. I have just brought it to the intermediate tower. So solving for three means three being moved to destination, I will move the two to intermediate. Then I will only look at the third disk and keep it at the destination. Then I will solve for the two disks. From the intermediate, I will bring to destination. How? I will pick this up, keep it here. Then I pick this one up, keep it here. Then I pick this one up, keep it here. Job done. If I was given 4, then what will I do? I will think I will have to keep this 3 in the intermediate. I'll forget about the fourth. I will think that my solution for 3 is already done. So these 3 I will keep in intermediate. The fourth one I will keep in destination. Then again these 3 from intermediate I will move to destination. This is how I will solve this problem. Then to solve it for 3, I will have to again solve for 2. So 3 to be moved to intermediate means 2 to be moved to destination. Then the third one to be moved to intermediate. Then again 2 brought to the intermediate. So 3 will be brought to intermediate. So now my target is 3 plates to be moved to intermediate. So then my target is 2 plates to bring to destination. So how to bring 2 plates to destination? I will just do like this. 2 plates to destination. Job done. I've solved for 2 plates to destination. So the third plate, now it's very easy. Third plate I keep to intermediate. And then I move this to intermediate. How? I keep it over here. Then I again pick it up, keep it over here. Then I again pick it up, keep it over here. So 3 plates move to intermediate. So if 3 plates move to intermediate, then I will pick the fourth plate and keep it to destination. Then my job will be to move these 3 plates to destination. So how to do that? 2 plates to source position, so that I can move this one over here, then the 2 from source to destination. So I will solve the problem now for 2 plates to be brought to source. These 2 plates to be brought to source. How to do? Pick this one up, keep it here, pick this one up, keep it here, pick this one up, keep it here. 2 plates move to source, 2 disks move to source. Then this disk I pick up, keep it here. Then this disk I pick up, keep it here. Then this disk I pick up, keep it here. Then pick up this disk, keep it here. So how have I done this? For 4 plates I solve it for 3. For 3 plates I solve it for 2. So the job is, if I have to do for n plates, I will move the n minus 1 to intermediate, then the nth plate to destination, then the n minus 1 from intermediate to destination. Job done. So let me go back to my PPT and show you that how to continue with this. Next step. Sorry, I go back to the PPT. So the next step, In the next step, I talk about recurrence relation. So for recurrence relation, I will give you another puzzle to explain what is recurrence relation. See what is recurrence relation. A number 1 comes. Next comes a number 5. With my next press comes a number 17. Can you say what will be the fourth number coming? You can guess. With my press, the next number that comes is 53. So what will be the next number coming? You can guess. The next number which comes is 161. What is happening? See, I will tell you what is happening. I take a pen and try to show you. This is 1. What is 1 into 3? It's 3. Plus 2, 5. This is 5. What is 5 into 3? 5 into 3 is 15. Plus 2, 17. What is 17 into 3? 51. Plus 2, 53. What is 53 into 3? 159. Plus 2, 161. So what will be the next number? 161 into 3 plus 2, 485. 161 into 3 is 483. Plus 2 is 485. Then 485 into 3 plus 2 is 1457. 1457 into 3 plus 2 is 4373. 4373 into 3 plus 2 is 13121, and so on the list continues. So this series of numbers is a recurrence relation where any number function n, fn, is f into n minus 1, previous number, into 3 plus 2. So what is the recurrence relation for this one? It is fn equal to 3 into fn minus 1 plus 2. Fn, consider fn 53. What is it? 3 into fn minus 1. What is fn minus 1 then? 17. 3 into that, 3 into 17, 51. Plus 2 makes it 53. Recurrence relation. But all recurrence relation will have an end point, because if you are talked about f10, f10 depends on f9. f10 depends on f9. So f9 depends on f8, f8 on f7, f7 on f6, f6 on f5, f5 on f4, f4 on f3, f3 on f2, and f2 on f1. But what if f1? F1, what will you do? You have to define that f1 is equal to 1, like over here you started with 1, because f1 is 1. That's why f2 is fn minus 1, f1 into 3, 3 plus 2. F3 is F2 into 3, 15, 5 into 3, 15 plus 2, and so on it continues. And so on it continues. This is recurrence relation where a function fn is dependent on a function on the previous function fn minus 1. Fn is dependent on the previous function fn minus 1. Let me now explain express tower of Hanoi as a recurrence relation. See how. Recurrence relation for the Tower of Hanoi, a game, a simple game of Tower of Hanoi expressed in mathematics. Tower of Hanoi, let me treat it as a function. Like you write f bracket, like that Tower of Hanoi bracket. Tower of Hanoi is a problem where you have to start from source. You can use the intermediate and move the plates to destination. You have to start from source, use intermediate, and move them to destination. How many? N plates. So this is a function f n. Check out, is not it a function fn to be expressed in terms of fn minus 1? How is it to be expressed in terms of fn minus 1? How to solve it? See how you solve it. Your first step is do the same function Tower of Hanoi, move the plates, not n plates, but n minus 1 plates. Remember, for 4 you use 3, for 3 you use 2, like that. So for n plates, you firstly move n minus 1 plates from source using destination
to intermediate. Like from source, you have to move n plates, you have to move from source to destination using intermediate. What you do is you now make the puzzle problem fn minus 1, because Tower of Hanoi function written as f, as if you are expressing it in terms of fn minus 1, that is Tower of Hanoi n minus 1 being executed to move from source to intermediate using destination. So for moving n plates to destination, you have moved n minus 1 plates to intermediate. You have kept n minus 1 plates to intermediate. Now you are left with the nth plate. So move that plate, move plate from source to destination. Move the nth plate from source to destination. And final step is then again execute Tower of Hanoi, that is again execute the function f to move the plates from intermediate, because they are now at the you had kept it at intermediate, move those n minus 1 plates from intermediate to destination, this time using source. Your job is done, but every recurrence relation needs to have an end point. For n, you will be using n minus 1. For n minus 1, you will be using n minus 2. For n minus 2, you will be using n minus 3. Like for 5, you will be using 4. For 4, you will be using 3. For 3, you will be using 2. But where is the end point? So the end point has to be mentioned, like any recurrence relation, from source to intermediate using destination, 2 plates to be moved. This is the end point. For 5 use 4, for 4 use 3, for 3 use 2, but 2 has to be defined. That how to move 2 plates from source to using intermediate to destination. That solution has to be given. So that solution is very, very simple. Move from source to intermediate, then the bigger plate from source to destination, then the plate from intermediate to destination. Your job is done. For 2 plates is very simple: source to intermediate, then source to destination, then intermediate to destination. Job done. So you have got the solution for 2 plates. If you can use 2 plates to solve for 3, 3 to use solve for 4, 4 to solve for 5, using this recurrence relation, job is done, and you have understood what interesting relation a computer game can also have with mathematics. I believe you have understood. If not, do play a game also. At least play the game. Mathsisfun.com was the website I used. Use that website and play the game. You will enjoy it. Thank you so much. Thanks to all of you.